SiddarthaVanam. Today I am going to discuss about the topic design model. So what's the design model? Design model is the second primary model of the architecture which models the design of your system. So the definition, the design model will show you the system how it is designed such that it can manipulate computer representation of those types. So by this model you can have a little control of facts of the domain, but you can have a great control about the model of the system. So can a complete design model can be built? In practical, the complete design model can't be built because even if it is built, it is very you can find it very comprehensiveness would make it impractical to use it directly. So models amplify your reasoning by focusing your attention on silent details. So a master model with all details cannot be effective. So we don't use a master model. So how to require an effective design model? So we use a combination of views, encapsulation and nesting, three together to find an comprehensive design model. So what is a view? A view is a projection of a model that reveals the selected details. We will use views to selectively narrow or focus on the comprehensive design model. So with the help of the views, we can get an idea of how the design of the model should be there, so that you can just go on with it. And what is encapsulation? Encapsulation mainly it includes two terms. They are boundary model and the internal model. These two terms deal with the encapsulation. In general, what is encapsulation? Encapsulation separates the interface of the element from its implementation. So we use the term boundary model to refer to model elements interface, since the term interface is commonly used to refer to programming language construct. That's it. So encapsulation in detail, you go on with the boundary model and the internal model later on. So what is nesting? What happens generally, most of the elements are internally structured. They have the substructures in the model. So an internal model of an element consists of small elements. So each of these elements can be described by a boundary model, and the implementation of the elements can be described by internals model. Consequently, a single element can be decomposed into a nested boundary and internal models. So this is called nesting. So what are the two types of models that we are doing the encapsulation? So with the encapsulation, the first model is the boundary model. The boundary model doesn't deal with the internal things, it only deals with the outsider view, mainly the system's design and how the system should be there. In general, the boundary model is what outsider considers system, which includes its behavior, interchange data and quality attributes. So it doesn't deal with the internal system at all. The boundary model describes what a user needs to know, understand how a system works. It encapsulates the system that hides internal details. So when developers change the internal design, users are undisturbed with the boundary model. So later on, what is the internal model? The internal model is another view of the design model that reveals the details of the internal systems. The details that are omitted from the boundary model. So the internal systems, how the internal system works and how the design of the internal system, that all is dealt by the internal model. Both the boundary and internal models are views of the design model. They are also related to each another by refinement relationship. So let's conclude how a design model can be very effective to the user than the other models. Being a second primary model, design model is most effectively used than the other models such as domain model, because the thing is, design model provides more details of the conceptual model software architecture. It provides the information to help you partition your design into manageable pieces. You can divide the system into pieces and you can just manage the system. Knowledge about how to solve the problems and set of architecture abstractions such as components that you can use to reason about software. So that's all. And with the help of encapsulation nesting, we go on with the design model to get a comprehensive and effective system. So that's all. I conclude the topic. Thank you so much.